Okay, good morning, students. We are continuing the loose structure lab. And so for this recording, we're going to be looking at formaldehyde, the CH2O. And so let's get started. For step one, what we want to do is we want to find how many valence electrons are in this molecule. So I like to draw myself a chart. We're going to find how many valence electrons are in each atom and then add them all together. So for chlorine, we're going to be looking at our PR table. So I'm going to write down what columns they are. So 1, 2, 3, 4, 5, 6, 7. And I write this because if we follow this trend, we can determine exactly how many valence electrons are in it. And so on here, carbon is in column 4. So it's going to have the 4 valence electrons. So we're going to write that over here, 4 valence electrons. And then for hydrogen and oxygen, hydrogen's over here in column 1, so that's going to be 1 valence electron, and oxygen's over here, so it's going to have those 6 valence electrons. So let's write those down. So 1 and 6. So then let me write the formula over here, just so we remember. So when we add them up, we're going to have 4 plus 1 plus 6. However, we do need to keep in keep in mind that there are 2 hydrogens, not just one. So to account for that, we're just going to times this by 2. That way, we know that each of those hydrogens brings in 1 valence electron. So the total for this molecule is going to be 12. So we go to step 2, and we think about the connectivity. So on here, we have carbon, we have hydrogen, or we have oxygen. And so looking at the trend of electronegativity, we look over here at our table again. We can see that oxygen's right next to fluorine, so that's going to be quite electronegative. Carbon's a little further away, and then hydrogen is all the way over there. So it has to be either carbon or hydrogen. However, thinking about which one can make the most bonds, hydrogen can only make one because it only has 1 valence electron, whereas then carbon can make up to 4 bonds because it has 4 valence electrons. So we're going to keep carbon in the middle. So for step 3, we're going to draw in the bonds between all the atoms to make that skeletal structure. So one between both the hydrogens and one between carbon and oxygen. And for me, I really like to keep track of how many electrons I have. So right here, I'm going to write down how many I use to make bonds. So 1 or 2, 4, 6. So I put, oh, that's the total. So the total was 12. And we just used 6. So that leaves us with 6 more electrons to use. So for step 4, what we're going to do is we're going to be filling in the lone pairs. So for lone pairs, we're going to want to put them on the outer atoms first. So we're going to put them on oxygen. So if I put lone pairs on each of them, that means that I'm going to have 6 electrons used, or I have 6 left from before. So that's 6, 6, and 6. And then we just use 6 around those lone pairs. So we are completely out of electrons. So we have 0 left. Okay. And due to that, we're going to have to go to step 5. So step 5, what we're going to do is we're going to be looking at octets, and we're going to see if we can fill all of them. So hydrogen only needs 2 electrons, so that one's good. The other hydrogen has 2 electrons. Oxygen here has a full octet. However, carbon only has 6 electrons around it because it has those 3 bonds. So it is missing 2 electrons. So what we can do is we can take these electrons and instead make it into a double bond. Thus, we will have this and this. And then we're going to keep the other 2 lone pairs on oxygen. And then we're going to see if this helps us to be able to fill all the octets. So let's look again. So carbon has 2, 4, 6, 8. So it has 4 bonds. It has 8 electrons on it. So it fills the octet. For oxygen, we have the 2 here, 2 here, and then these two double bonds. So that's going to be 8 around it, so it fills its octet. So with that, we know that this is going to be our final Lewis structure. Okay. We used all the 12 valence electrons. We checked the octets. The hydrogens are also happy, so that's going to be our final structure. So now, to be able to find out the geometry, we're going to use the table that was given on, or in the procedure. And so looking here, we have to find out how many number of electron sets are around our molecule. And so looking at this, we have 1, 2, 3. So 1, 2, 3. Okay, so we're going to be on this one. So it's going to be trigonal planar for our electronic geometry. So trigonal planar. And then for molecular geometry, on this one, we need to take into account any lone pairs. And so as we look at this carbon, it only has bonds. It doesn't have any lone pairs. Thus, we're going to put that 0 here. Sorry that line's in there, but it is a tetrahedral. Oh, sorry, I misspoke. It's not tetrahedral because we didn't have the 4 electronic groups. So scratch that. It is going to be this one, the trigonal planar. So it should be the exact same as the electronic geometry. Okay, perfect. And so what we're going to do next is we're going to be looking at this in 3D. And to be able to do that, I am going to use an app or an online website, which is going to be called MolView. And so with MolView, you can look at all the atoms in 3D. It's really helpful to be able to look at an atom in a different way. So let me just erase all this and put in the atom we made. So I'm going to put my carbon, I'm going to put 2 hydrogens, and I'm going to put our oxygen. And I'm going to make single bonds between carbon and hydrogen, and then a double bond here. And then I'm going to use this broom to clean it all up. And if we don't draw in the hydrogens, that's what it's going to look like. So now let's look at our 3D model. So we can see that the white ones are going to be the hydrogens, this is going to be our oxygen, and this is going to be our carbon. And as we can see, they are completely planar. They are all they are all on the same plane, and that's what it's going to look like. So that's going to be it for our formaldehyde. Hope you guys learned something, and see you in the next one.